The topic is triple integrals in spherical coordinates. So let's do this example. Write down the triple integral in spherical coordinate representing the volume below the cone z equals square root of 3x squared plus y squared, and inside the cylinder x squared plus y squared equal 3. Z positive, of course positive because it's square root of something. Alright, so first let's do the cylinder. Well, actually, square root of 3 and then right, so let's assume cone is going all the way there, right? And so the volume will be below the cone and inside the cylinder, and z is positive, in other words above xy plane. So it's going from here alright, so first thing what I want to know, I don't know if I'm going to need this, but I want to know at what z they intersect. So we know that z equal square root of 3x squared plus y squared. So I want to know the intersection at which z the cylinder and the cone intersect. I mean, you can tell, see, x squared plus y squared equal 3, so I could replace this by 3. So this means z is equal square root of 3 times 3, which is square root of 9. So z equal 3. 3 minus 3, but we know z is positive. So this is z equal 3. Alright, what else? Well, the good thing we can even find, we can use, well, let's do it differently. We can use a phi tangent 3 over square root of 3, or we can do it this way. Hold on. So we're looking for phi. So how do we find a phi? Like always, we can look for the intersection. Let me write it down. Of the cone and the zy plane and zy plane. At the zy plane, we know x is equal 0, which means z is equal square root, so I'm plugging a 0 for x, 3 times 0 squared plus y squared, which means z is equal square root of 3 square root of y squared, z equal square root of 3 absolute value of y. Absolute value of y is equal 1 over square root of 3z, using absolute value y equal minus plus 1 over square root of 3z. This means z is equal minus plus square root of 3y. Now if I solve, if I try to graph it, so in other words, this is, it's an absolute y, z equals square root of 3y. So the equation of this one will be z equal minus square root of 3y. Right? So basically, so let me pick just one. When y is equal 1, y equal, go back here, y equal 1 means z equal, something is wrong. Yeah, it means z equal, I'm going to use the plus one, this is what I need. So z equal square root of 3 times 1. So z equals square root of 3. So 1, this is square root of 3. So let me do it here. This is square root of 3. This is 1. Therefore this has to be 2. Therefore this is pi over 3. So this angle that's left is pi over 6. So phi is equal to pi over 6. Alright, so now we know that phi is going to go from pi over 6 to pi over 2. Pi over 2, it's confusing because remember phi equals 0 is here. Let me write it. Phi equals 0. Let's do it here. This is phi equals 0. This now we prove that it's equal pi over 6. And then this is phi equal pi over 2. So I'm going from pi over 6 to pi over 2. So let me go back here. Where do I write this? I know my phi goes from pi over 6 to pi over 2. I want the theta to go the whole revolution, so I want my theta to go from 0 to 2 pi. Now the only thing I need to find, the rho is going to go from 0 from here to here, right? From 0 to the cylinder. So what is the cylinder? The equation of the cylinder is x squared plus y squared equal 3. So I need to convert it to spherical. So x is rho sine phi, but I need to sine phi cosine theta. I need to square everything. Plus y is rho sine phi sine theta, but I need to square everything, and we want this to be equal 3. Let's factor rho squared sine squared phi, factor of cosine squared theta plus sine squared theta should be equal 3, but we know this is equal 1. So rho squared will be 3 over sine squared phi. Therefore rho will be square root. It's minus plus, but we know rho is positive, so 3 over sine square phi. So square root of 3 over sine square of phi. Alright, so now let's write the double integral, or the volume. So v of e is equal, I want my theta to go from 0 to 2 pi. I want my phi to go from pi over 6 to pi over 2. Now I want my rho to go from 0 to square root of 3 over sine square phi. And then the rest is just copying it, so it's rho squared sine phi d rho d phi d theta. And that's it for